Hello everybody and welcome back to another episode of Magnificent Math with Mrs. Murray. Bum, ba, dum, bum. Today we're going to be moving on to 9.2, which is quadratic inequalities. So uh, basically there's a few different strategies that we can use. There's 4 in total. So the first one is that we can graph the function. So you would graph that just with an equal sign and then identify the values for x that lie on, above, or below the x-axis, depending on the inequality symbol. You can also determine the roots of the related equation and use a number line to test points to determine the intervals that satisfy the inequality. We can determine when each of the factors of the expression is positive, 0, or negative, and then use those results to determine the sign of the product, or we consider all cases for the required product of the factors to find any x values that satisfy both these conditions. So it sounds like a lot, sounds a little bit confusing, but we're basically going to I'll walk you through all these different types of examples here. So this first example, we're going to solve, this one we are going to solve using roots and test points. So in order to graph, or first thing that we're going to do is just factor this so that we can find out what the roots are. And the roots are x equals 3 and x equals -1. So from there, what we're going to do is we're going to set up a number line. So these dashed lines here, those are our roots at -1 and 3. And what we're basically going to do next is we're going to choose a test point that lies within each of these regions. So something that's less than -1, I've chosen point -3. And I'm going to substitute -3 in for x in these two factors. And I'm going to find that that is equal to +5. So the values over here are going to make this inequality positive. Okay, but this part of the equation is supposed to be less than 0, so we wouldn't want to include that part in our solution. Next thing we're going to do is test a point in between -1 and 3, and the easiest point there is to pick 0. So I substitute 0 in for x and find that the equation then equals -3, and that is less than or equal to 0. So that's true for that part of the number line, sorry. And then the last step is to choose another point, and this time I'm going to choose 4 for x, so I substitute that in, and then I find out that it is equal to 5, which does not satisfy the inequality, so the values over here are not included. So our solution would be x such that x is greater than or equal to -1 and less than or equal to +3. And then of course it's an element of real numbers. Okay, so that was using roots and test points. So in the next example, what we're going to do is use case analysis. So what we want to do first is we want to rearrange this equation so that our x² term is positive. It's always just easier to work with the positive coefficient. So we rearrange that, and then of course we're going to factor again. Once we factor, we should, I don't think I wrote it down, but our values that we're going to be looking at is when x is less than 4, sorry, x is greater than 4 or x is greater than 3. If that's the case, then these two factors, when we multiply them together, are going to be greater than 0, which is what we want. So what we're going to do is we're going to draw a little number line here, and we need to ask ourselves, when is x greater than -3? So x is greater than -3 from this point moving forward. Okay, so any value for x that's greater than -3 would satisfy that equation, as well as any time that x is greater than 4. Okay, so that's the first case, is when both factors are positive, because anytime you have a positive and a positive number, it equals a positive. Our second case is going to be Now I've lost, oh, sorry. Our second case is going to be when both factors are negative. So when this would be a negative value and this is a negative value. So in order to do that, we're just going to flip this sign here and say that 0 is greater than this, which would mean that if we solve this inequality, we have 4 is greater than x, and if we solve this inequality, -3 is greater than x, and we make a timeline again, and this time we're going to highlight when -3 is greater than x, or x is less than -3, which would move this way, and then from here, it would be moving the opposite way as well. So when x is less than 4. Now we need to think about where these two lines overlap. So at this point, they overlap, and at this point, they overlap. So our solution in this case is going to be x such that x is less than -3, or x is greater than 4. Okay? So we're determining when it satisfies these cases. And our last example is using sign analysis. So this time we're actually going to use the quadratic formula to substitute and solve. When we solve, we find that x equals 4.8 or x equals -1.3. And now what we want to do is we're going to basically do a sign analysis for each factor. So this is our first factor, because if we move this over to this side, we get x minus 4.8. If we move the 1.3 over, we get x plus 3. And then if we put the two beside each other, we would have our two factors of x equal to, sorry, we'd have x minus 4 multiplied by x plus 3. Now what we want to do is we're going to set up sort of a number line, okay? And at this point, for the first factor, at this point we're going to have a value of 0. So anything to the right of this is going to give us a positive value. So if we substitute 5 in, it's going to give us a positive answer. If we substitute anything less than that, it's going to be negative. For our second factor, at -1.3, this is going to equal 0. So anything greater than that is going to give us a positive value. Okay, and anything less than that would give us a negative value. Now what we need to do is look at both of them together. And when we look at both of them together, here we're going to have value of 0 and a value of 0. And if we look at everything to the left of -1.3, we have a negative and a negative. So if we multiply those two together, it's going to become positive. Between these values here, we have a negative and a positive, so that's going to become negative. And then on the right side, we have positive values. So we're looking for when it's greater than, so what we are going to do is look at our solutions when they are positive. Let's see if I can move this. And when they are positive, it's when x is greater than 4.8 or x is less than -1.3. And if we were to put it into our quadratic formula without simplifying into a decimal, if we gave it exact form, this is what it would look like. Okay? So it can be a little bit confusing how to analyze each of those. But basically, you're just breaking it down into the factors and then trying to figure out for which values of that does it satisfy the inequality, okay? And although you don't, you might be more comfortable solving one way, you are going to be asked to solve all 4 ways in your textbook as well as on your exam. So you need to make sure that you're comfortable with solving those. If you have any questions, I can definitely answer them. I'm not in class tomorrow with you, but I will be there on Monday. So work on what you can tomorrow. Hopefully the sub can help you, or you guys can work through things together. And we will see you in class on Monday.